Students, in this module, we will learn how to construct the confidence interval for the population proportion. Now, for an experiment where we have two kinds of probabilities, one is known as P and other is known as 1 minus P, where P is the probability of success and 1 minus P is the probability of failure, and we are interested in calculating the probability of exact X successes, then this target or objective may be attained using the binomial distribution. Now students, if n is quite large, then we will be applying the normal approximation to the binomial distribution. Usually it is being said, while this is a rule of thumb, that if NP is greater than 5, that is appeared here, or n into 1 minus p, if it is greater than 5, the binomial distribution will be approximated by the normal distribution. Now students, there are two schools of thoughts in that. Some of them, they state that NP has to be greater than 5. But you will find in various texts that even the NP greater than 10 criterion, you can, find out. So, NP greater than 10 is somewhat more conservative as compared to the NP greater than 5. But usually what we would have to do, that whenever we find that n into p is greater than 5, it is better to perform the test using the normal approximation to the binomial. Now students, binomial distribution, as we know, it has two parameters. One is the n and other is the p. N is the total number of trials in our distribution and p is the probability of success. So if we are applying the normal approximation to the binomial using this criterion, so students, we are converting the discrete distribution into a continuous distribution. So अगर हम उसको convert कर रहे हैं, तो हमें उसके नई distribution के parameters भी known होने चाहिए. So students, for normal distribution, there are two parameters of interest. One is the mean, which is denoted as mu, and the other is the variance, which is denoted by the sigma square. So, for the binomial distribution, we would have to find out that mu and sigma. And how we can do that? Mu is obtained as NP, which is also the mean of the distribution, and sigma will be obtained as NPQ positive square root, that is the standard deviation of the binomial distribution. अब स्टूडेंट्स, यहाँ मैं ये भी आपको बताती चलूँ कि जब आप डिस्क्रीट वेरिएबल को कंटिन्यूस वेरिएबल में कन्वर्ट करते हैं, देन यू वुड हैव टू अप्लाई द कंटिन्यूटी करेक्शन एज वेल. दैट मीन्स आपका जो रैंडम वेरिएबल है एक्स डिस्क्रीट, उसमें ईदर यू विल ऐड 0.5 और यू विल सब्ट्रैक्ट 0.5. सो यहाँ जो ऑब्जेक्टिव है हमारा वो ये है दैट द पॉपुलेशन प्रोपोर्शन इज अननोन and we need to estimate it from the information contained in the sample. Now, how we can do that? There are two ways to do that. One is known as the point estimation and other is known as the interval estimation. So, by point estimation, what do we mean? That means we would have to find out the population proportion from within the sample. And how we can do that? P hat equal to small x over n. So this is the one of the information which we obtain from the sample. Now students, ये अब हमने क्यों identify किया, क्यों calculate किया? Because we are using this point estimate to calculate the interval estimate. The problem with the point estimate is the reliability. So we can't actually test the reliability of the point estimate. That is why we would have to calculate the interval estimates. So students, उसको कैसे construct करेंगे, उसका क्या procedure है? Confidence interval is being calculated as point estimate plus minus the margin of error. Where what is the margin of error? It is being calculated as the critical value multiplied by the standard error. सो स्टूडेंट जो फॉर्मूला मिलता है हमको उसको हम कहते हैं 100 into 1 minus alpha % confidence interval for P. So students अगर आप देखिए ये वो फॉर्मूला है जिसको यूज करके we are going to estimate the unknown population parameter, that is the population proportion. So this P hat is the point estimate plus minus Z alpha by 2, which is the critical value. We will obtain it from the normal, standard normal table. And finally, this is the standard error of the population proportion. So let us take an example so that you can better understand that how to calculate the population proportion and how to estimate it through confidence interval approach. The problem stated, a researcher has conducted a research on liking of a product. Suppose a sample of size 200 revealed that 140 respondents liked the product. So 140 students वो हैं जो 200 में से किसी particular specific product को like करते हैं. What we are required to do, we'll have to construct a 95% confidence interval for the population proportion. So students, as I've told you earlier, the first thing we would have to do is to calculate the P hat. So students, वो हम कैसे करेंगे? P hat is x over n. X हमारा यहाँ क्या है? 140 and 200 are the that is the total sample size. So इन दोनों की रेशो लेके हमने जो obtain किया point estimate, that is 0.7. अब इसको हम यूज करेंगे to calculate the interval estimate. So students, by plugging the information into this particular formula, we obtain this information. Now here P hat we have just calculated as 0.7. P hat is 0.7. 1 minus P will be 0.3. When we will subtract the 0.7 from 1, that will provide us with 0.3. And students, हमारे पास 200 था. How we get this P critical value as 1.96? So students, in some previous discussion, I've told you about confidence coefficient. So confidence coefficient students हमारे पास ये है जो हम construct कर रहे हैं confidence interval जिसके लिए. So 1 minus alpha is 0.95. So यहाँ से आपके पास alpha मिलेगा 0.05. अब आप ये देखिए यहाँ पे confidence interval is a two-sided interval. क्यों? ये देखिए due to this plus minus sign. एक हमें lower interval मिलेगा और एक upper interval. अब अगर आप alpha 0.05 को standard normal table में जाके इसके against value देखेंगे for two-tailed, that will be equal to 1.96. Alpha को students मैंने divide किया 2 से, वो मुझे मिला 0.025. So 0.025 को जब आप inverse use of table करेंगे standard normal के table में from 0 to z, तो you will be getting this value 1.96. After plugging this entire information, we get this required interval. इसको कहते हैं हम lower limit of the interval, and this particular limit is the upper limit of the interval. So students, we have learned in this module that how to estimate the population proportion. So we are expecting that our population proportion is expected to lie within this interval with 95% confidence.